Hello students, now I am here with the second module of the chapter a pair of linear equations in two variables. In our last module, I told you how we can graphically represent a pair of linear equations in two variables. I also told you that we will have three different situations. To deal with that, I'll start with the example which will make the concept clear in front of you. So here I am starting with graphical method of finding solution to a pair of linear equation. I start with one example. The example is draw the graph of the following pair of linear equations, and the equations are 3x plus 2y is equal to 5. This is equation 1, and second is 2x minus 3y is equal to 7, equation 2. So we are having two separate equations. So for each equation we will make a table. Here I am making a table for equation 1. So what I told you, on our own choice we will take the value of one variable, and for that value we will find out the corresponding value of another variable. The choice would be completely yours. What do you want to select first, x or y? Here I am selecting x. So for x is equal to 1, I am talking about equation 1. So when we put x is equal to 1, we are getting y is equal to 1, and so on. So I have taken three different points here. Okay, the same I have done for equation 2. So here also I have taken the values of y, and for that I am getting the corresponding values, I am taking the values of x, and for that I have taken the corresponding values of y. Now simple Cartesian plane is drawn and the points have been plotted. Plotting the points you are knowing since class 8th. So it is very easy. So for each point you are having a set of coordinates and you will plot all the points, and then with a straight line we find that we get two straight lines. Obviously we would get two straight lines because we are having a pair of linear equations. Here we get an intersecting point, that is the point where the lines are intersecting each other. So in my last module I told you that if we are getting two lines which are intersecting each other, one point will be common and that point will be the solution of the equation. Okay, so we get an unique solution. Unique means one and only one solution we will get. Now if we observe it, if we observe a1, a2, b1, b2, we find that a1 by a2 is 3 by 2. a1 and a2, you all are knowing that what is a1 and a2. a1 is the coefficient of x in equation 1 and a2 is coefficient of x in equation 2, and same is for b1, b2, coefficient of y in 1, coefficient of y in 2. So what do we find? That 3 by 2, and here we are getting 2 by minus 3. Obviously these two are not equal. 3 by 2 is not equal to minus 2 by 3. So a1 by a2 is not equal to b1 by b2, and when they are not equal, what we are getting? We are getting a pair of intersecting lines. Now I am taking the help of another example. The other example says that draw the graph of 9x plus 3y plus 12 is equal to 0, 18x plus 6y plus 24 is equal to 0. Again we are getting two different equations, equation 1 and equation 2. Now what do we do? Again I make two tables in the same way I did in the first question. I took the values of x and for that I got the corresponding values of y. The same I did for equation number 2. So now when we plot the points, what do we find? This is our Cartesian plane. This is x. This is x dash. This is the Cartesian plane. This is y and this is y dash. So this is the Cartesian plane. Now I have plotted the points. The points are like 0, -4, the point is here, -3, 5, the point is here, 1, -7, the point is here. For second, if I am taking 0, -4, the point is here, 1, -7, the point is here, -2, 2, the point is here. And we find that all the points, 3 points for this and 3 points for this, all the points are falling on the same line. We are not getting any other line. It means the lines are coincident. Coincident means they are falling on each other. So what do we get? We are getting two lines which are falling on each other. They are called coincident lines. Now we observe what is the relation between a1 by a2. So a1 by a2 is giving us 9 by 18 is equal to 1 by 2. b1 by b2 is equal to 3 by 6. It is also equal to 1 by 2. Now let's see what happens. c1 by c2. c1 by c2 is equal to 12 by 24 is equal to 1 by 2. Thus what do we find? All are equal to 1 by 2. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So when we are getting this condition, what we are getting? We are getting two coincident lines. That means the lines are falling on each other. Now I am taking the help of the third example. The third example is draw the graph of x plus 2y is equal to 5, equation 1, and 3x plus 6y is equal to 12. This is equation 2. The same I have done. I have made two different tables. With the help of the tables, I have taken the pair of the coordinates and plotted the points. So if we see the table carefully, we are getting for equation 1 -1, 3, 3, 1, 5, 0. These are the 3 points. Again for the second equation, we are getting these 3 points. What we observe when we plot a line, when we plot the points and then join the points with a straight line, we are getting two straight lines, but there are two separate straight lines. They are not touching each other. They are not intersecting each other. So here what we get? Here we get a pair of parallel lines. Now if we compare between a1, a2, b1, b2, so what do we see? a1 by a2 is equal to 1 by 3. b1 by b2 is equal to 2 by 6, that is equal to 1 by 3. And c1 by c2 is equal to -5 divided by -12, that is equal to 5 by 12. So what we are getting? That this and this, these two are equal. a1 by 3, 1 by 3. So a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. Okay? So this is what we observed from these 3 examples. I have altogether discussed 3 examples with you. Okay? What observation we got? It follows from the above examples that the pair of linear equations a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0 will represent. What will they represent? They will represent intersecting lines if a1 by a2 is not equal to b1 by b2. That means this is the condition for two lines to be intersecting. That means without drawing the graph, if we compare the coefficients of both the equations and if we are getting a1 by a2 is not equal to b1 by b2, it means whenever we draw the graph, we will get intersecting lines. So by this you can easily judge, and such kind of questions you will get in exam. That means they will give you these two are equation and tell me what kind of graph we will get? Intersecting, parallel or coincident. So by only checking it, you can tell it. Is this clear? Now I proceed. In this case, we will have unique solution. Unique solution, once again I am telling you, one and only one solution. The point of intersection of the solution. What will be the your solution? The solution will be the coordinates of the point of intersection. X coordinate will be the x value, the value of x, and y coordinate will be the value of y for both the equations. Now it will represent, that means a system of linear equation will represent coincident lines if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. In this case, it will have infinite number of solutions because all the points falling on the lines will be common for both the equations. So every point on the line will be a solution. Whichever point we take, all will be the solution because all the points are solution of both the equations. Now, the third case, parallel lines. When we will have parallel lines? When a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. In this case, they do not have a solution. Okay, because there will be no common point. So what we observe in case number 1, when we are having intersecting lines, we are having a single solution. When in case number 2, when we have coincident lines, we are having infinitely many solutions. And case number 3, when we are having parallel lines, there will be no solution. So in short, I can say case 1 and case 2 are called consistent system of linear equations. And in case 3, it is called inconsistent system of linear equations. In exam, you may get questions like this. Identify only by seeing the system of linear equations whether they are consistent or non-consistent. So by comparing the coefficients and the constant part, you can easily judge it. Is this clear? So thank you and have a wonderful day.